Okay, guys, we're going to talk about some of the concepts of geometry, which are going to be illustrated here with the geometry sketchpad. And which you utilize in some of the problems we looked at, and we'll continue to look at. So here we got circle, any circle. We got the radius. Okay, there's a tangent. The tangent can be constructed perpendicular to the radius at the point of tangency. So, in other words, if I were to select that and select this point, I could construct the perpendicular line. That would be the tangent line. So the idea here is that there's always a right angle formed between a tangent and between the tangent and the radius. Okay, and again, any way I sweep this, okay, then that perpendicularity will always be maintained. Of course, the perpendicularity is kind of highlighted by the slope. Okay, and so if I took the slope of these two segments and looked at them, and it may not be obvious here in this arrangement, but one thing that's true: if slopes are perpendicular, then that is to imply that their product is -1. So I could kind of illustrate that here this way. I take that slope times the other slope, and it's always going to equal -1. So that's going to illustrate that. Where'd it go? I don't know. Okay, there it is. Okay, that's going to illustrate that is all that perpendicular. Okay, the radius and the radius and the tangent are always perpendicular. A key concept, very key concept, okay, because if you have the equation of this line and you have the point of tangency, then effectively you have the equation of the line containing the center of the circle, okay. There's another thing that comes into play here that we'll take advantage of, okay. We're going to just put a couple points on this line, and we're going to take a look at the chord that's formed with those 2 points. So I got 2 points here on the line, 2 points on the circle rather, okay? Through any 2 points on the circle, there is a chord that can be constructed. The perpendicular bisector of that chord will contain, okay, the center of that circle, okay? So here it is. There's the perpendicular bisector. And regardless of, this is going to, again, show perpendicular nature. Sorry. Okay. Delete that. Perpendicular nature is shown here. All right. And that is maintained, okay, through any chord. Okay. So, and even if that chord were to contain this point of tangency, all right, we're still going to have that nice perpendicular relationship, okay? Okay, guys, we're back. We want to demonstrate another concept, okay? We'll take any 3 points. Obviously, through any 3 points, there is a triangle that can be formed, okay? No, shouldn't have any trouble convincing anybody of that, okay? Now, okay, there is also a circle which contains these 3 points, or this triangle, which circumscribes this triangle. Of course, the objective would be to try to find where the center of that circle is. Well, okay, the center of that circle would be the perpendicular bisectors of the sides. Okay, so if I were to find the midpoint of each side, okay, and if I were to subsequently select the midpoint and the segment, okay, and construct the perpendicular, we would find that those perpendiculars all converge at one point, okay, and that point would be the center of the circle. And basically, I don't even have to find the third; it's guaranteed to fall in there, okay. So in other words, I took the perpendicular bisectors of the sides and found their point of intersection which is the center of the circle. So I should be able to construct a circle. If this is my center, reaching out to A, B, and C, and that's a circumscribed circle. So, and again, I can illustrate this regardless of how I change this circle. We maintain that we have an inscribed triangle. Acute triangles. This point of intersection is the circumcenter. Okay, so that circumcenter for an acute triangle is inside the triangle. Point D is inside the triangle. For a right triangle, it should be at the midpoint of the hypotenuse, right there. And for an obtuse triangle, it's going to be outside. And again, we didn't demonstrate it, but again, I should be able to take this perpendicular bisector of BC and construct it, and it will do that. Okay, I'm going to construct the perpendicular bisector of BC, and you should see that it also converges at point D. Okay, so if we're given any 3 points, okay, there's a triangle that contains them, but more so, there's a circle that can be circumscribed about that. So that circle would be found, its center would be found by taking the perpendicular bisectors of the sides, okay? The perpendicular bisectors of the sides would converge at the circumcenter, which is the center of the circumscribed triangle. And just bring that up full screen again. Oops, sorry about that. Okay, so there it is again for you, illustrating that. Key concept, we will do some problems and illustrate how those problems, you can use your calculator programs to look at those problems. Okay, so there you have it.